Assalamualaikum everyone. Today we will be discussing how to solve moles calculation. Let's get started. Okay, moles calculation questions are mostly asked in paper 1, paper 2 and paper 4. But this time in 2024 made you an examination in O levels in paper 2 only one mole question came, and in paper 4 no mole question came. So according to this, there are more chances that in P1 it would be asked. There are four formulas to solve moles calculation. So let's have a look on the first formula. To solve this is the first formula which you can see on your screen. Moles equals to number of particles divided by 6 into 10 power 23. What is the 6 into 10 power 23? This is the Avogadro's number and it is the fixed number. To calculate moles, you can use this formula when the number of particles, for example, you are given moles and you need to find the number of particles present in that specific molecule. So you can use this formula. And if you are given the number of particles, so you can divide the number of particles using 6 into 10 power 23. So you can easily get moles. Let's look at the second formula. This was the first formula. This is the second formula, which is moles equals to given mass divided by mR. This given mass is always in grams and it is given in the question and you have to divide it by the molecular mass. What is molecular mass? Molecular mass is also known as atomic mass, molecular mass or formula mass that is expressed in grams. You can find this molecular mass using the periodic table given. So we will look into some examples so you can have a better understanding of this. Then we have the third formula, which is given volume divided by 24 dm3. Firstly, you should know that at room temperature, 1 mole of any gas equals to 24 dm3. And secondly, you should know that 1 dm cube equals to 1000 cm cube. So this is the unit conversion of 1 dm cube into 1000 into cm cubes. So this was our third formula, given volume divided by 24 dm cube. Sometimes it's like that you are giving the moles or you find the moles using the other calculations given in the question, and you are asked to find the given or not given the volume. If the volume isn't given in the question is asking you to find out the volume, so you can use this volume formula to find out the volume. What you have to do is just to rearrange the formula. The formula is moles equals to given volume divided by 24 dm cube. So if the moles are given, so you will write any value of moles which is given in the question and multiply this 24 dm cube. You will go here and multiply and you will find the volume. So this is the fourth formula for mole calculation, and it is moles equals to concentration. This C is concentration and this V is volume. This is the fourth formula to calculate moles. These were the four formulas which you can use to calculate moles in your paper. I hope you understood it. Let's look at a few examples. The first example I got it from past paper, and the year of this question is winter 2022 P12 MCQ paper है ये. Question number 13. Which mass of the oxygen gas combines with exactly 16 grams of sulfur to form sulfur dioxide? So to solve this, what you have to do is write an equation. They are saying that sulfur to form sulfur dioxide with like S plus oxygen, it's forming SO2 sulfur dioxide. Okay, you can find moles. The given mass is 16 grams. The formula I told you above. You should memorize these four formulas. Now, see. In this question, which formula you have to use? If you're thinking the formula you have to use is given mass divided by mR, you are correct. The second formula we have to use The given mass is 16 grams and the MR of sulfur. Let's see the MR of sulfur in P1 and P2 periodic table is given. So no need to worry. Using periodic table, you can find the MR of sulfur, and this is the sulfur. It is in group 6. The MR of sulfur is 32. This is the MR of sulfur, the big one, the greater number. So 16 divided by 32, which is 0, which is 1 upon 2. When 1 upon 2 is solved, it is 0.5. So the moles of the sulfur is 0.5. So we can say that while looking at the equation, 1 mole here gives 1 mole here. So the ratio is of 1:1. If the moles of sulfur is 0.5, so the moles of oxygen will also be 0.5. According to this, the exact mass of sulfur is 16 grams. So the exact mass of oxygen will also be 16 grams. So the correct option is C. Then here is another question. This type of questions usually appear in past papers. So you can see it, and this type of question comes in P1 especially. What is the number of molecules in 500 cm cube of oxygen under RTP? RTP means room temperature and pressure. So in this, we have to use ratio method. As I told you previously that 1 mole of any gas at RTP equals to 24 dm cube. So according to this, 1 mole of oxygen equals to 24 dm cube. Now, they are asking that 500 cm cube of oxygen under RTP, number of molecules in 500 cm cube of oxygen under RTP. What you have to do that 1 mole of oxygen equals to 24 dm cube under RTP. So under RTP, 500 cm cube, this is cm cube, equals to x moles. So while doing cross multiplication, you can easily find the number of moles. Let's do it. So we have to find the answer in cm cube as it is given here. You can see cm cube, 500 cm cube. So we have to convert this 24 dm cube into cm cube firstly. When we convert this 24 dm cube into cm cube, it would be 24,000. Let's do cross multiplication. 24,000x and 500. Now, this 24,000 will shift towards left and 500 would be divided by 24,000. And this is the x. Let me calculate it. 500 divided by 24,000. And the answer for the x is 0.0208. This is the answer, and these are the number of molecules present in 500 cm cube of oxygen at RTP. So by these two examples, I hope you understood how to solve mole calculations. Thank you.